I'm very known for bringing my own props to basically every presentation I do. So this is the first one. You will see 3 in total today in today's presentation. So let me pick out the second one, which is the clicker, which is very important to navigate through my slides. So today's presentation has the title, Should You Bring Your Umbrella, like I did today, if you know it's going to rain tomorrow? Well, I brought my umbrella, despite the fact that it's the most beautiful weather outside I could imagine. I traveled to Japan quite a bit on my bicycle. I was driving from Tokyo to Takayama, to Kyoto, Nara, Osaka. It was a beautiful trip, and it rained, unfortunately, 9 out of 10 days. This is what makes this country so green and beautiful. You need to appreciate it. But it also means you need a lot of umbrellas, which is okay. It's good for the umbrella industry. So, but is it always the right thing to do? Is it always the right thing to prepare like that, bringing your umbrella, if you think tomorrow is going to be rain? And the big question is not so much just to be prepared. The big question is that the forecast alone, the idea that you know what's going to happen tomorrow, is not enough to allow you to make a good decision. You need more information, and we will discuss this in this presentation. What kind of information am I talking about? And then you can actually make the right decision. And the right decision leads to the right action. And this is, if you don't take away anything else from today's presentation here, this is my key message to you. If anybody sells you insights based on your data, this is a nice start. This is the basics. But that actually doesn't help you at all. Knowing what's going on around you, knowing what has happened in the past, is actually not that helpful. It's just the first step. You need to know what you're going to do today, to get to a better outcome tomorrow. What is the right action, okay? Not just knowing, doing the right thing. If you do this, you have a huge chance and an opportunity for you. Gartner, the analyst firm, they predicted that by 2018, only 2 years from now, or 1.5 years maybe, global industries will be completely disrupted. More than 50% of all the industries in the world will change the way how they do business thanks to something they call advanced analytics, which is machine learning, predictive analytics, text analysis. That's amazing. How could that happen? How could we disrupt the largest organizations in the world? Just through insights? No. And this is the important thing, as I said before. If you just know something, that's good. But if you change the way how you do business, that is really having some impact. That is really what transforms your business. It's what you're doing, not just what you're knowing. So in my opinion, this is even bigger than the biggest technology trends we have seen in the past 10 years. This is bigger than mobile. This is bigger than cloud. Trust me on that. Why? Because those have been basically IT trends. Having access to a distributed network of computers where we can actually offload our data and our computation is a pretty good thing for IT. But it doesn't necessarily change the way so much you do business. Knowing what's going to happen, getting to the right course of action, that's changing your business. Okay, so enough of, that was a little bit too fast. Here's my second prop. Enough of motivation. Here is a prop. I call this my foldable cup. You need to give me a second. Ta-da, a cup. I would like to do a small experiment with you. Look at this cup, think about something, like maybe some nice tea, or a beer. I'm from Germany, I think of beer sometimes. So you might think about something like that. I think about something different. What I think about is 473 milliseconds. Okay, by now you probably guessed that I'm a little bit strange, but that's not really the reason why I'm thinking 473 milliseconds. The reason is it takes exactly 473 milliseconds for this cup to drop to the floor. 473 milliseconds, less than half a second, okay? If this would not be a paper cup, my foldable cup, my special prop I brought, but it would be an actual glass, and if I would let this glass drop, now something amazing happens. I look into your faces. You see me dropping this glass. You realize, oh my God, this glass is going to fall on the floor and it's going to crash. And you realize all of this in less than half of a second, and you still have enough time to change your facial expression to something like looking a little bit shocked. And I still have enough time to see your faces and think, oops, 80% of you look shocked now, so I can now create the prediction with the probability of 80% this glass is going to break. This all happens in less than half a second. We human beings are amazing. I mean, think about this. How could you know that this glass is going to break? You have never seen this particular glass breaking before. You have no idea. You have seen this glass for the first time in your life, and still you can anticipate what is going to happen. How is this working? Well, you didn't see this particular glass, but you saw similar glasses before in your life. A cup of tea, a plate, a glass, all the same thing. Dropping down to the floor, and you can learn from those experiences and predict the future. And this is exactly what machine learning is doing. It learns from experience, from data, and builds models like you do in your brain to predict, for example, well, this is a glass, the floor is hard, the height is high enough, this glass is going to break. So why is this important? Why is it important that we are able to predict the future? Well, if we only knew what's going to happen, we can do something. We can do something. That means there is the action again. We can, for example, take a cushion. I didn't bring a cushion. I thought about the foldable cup, the umbrella, the clicker. I forgot the cushion. But next time, maybe I bring a cushion as well. I can maybe use a rope. Okay. So you could take a cushion and put it under the glass. You prevent it from breaking. The glass falls down, the cushion is there, it secures the glass, it doesn't break. Great. You just saved a glass. Now you might think, oh, that's good, so I know what's going to happen. It breaks, or it will break. I know the right course of action, bring a cushion, put it underneath. Now I can actually stay on the safe side. I can put cushions everywhere. All over the world, I can place cushions. Why is this a stupid idea? Well, it's a stupid idea because cushions actually cost money. This looks like an IKEA advertisement. Do we have IKEA in Japan? Good to know. Doesn't it look like an IKEA advertisement? I think it looks like an IKEA advertisement. Let's say $10 US dollars per cushion. So you could buy all of those cushions, put them everywhere, and then there's no risk. All glasses are safe. Why is this a stupid idea? Because the stupid cushions are even more expensive than the glasses. So it's not a good idea to solve the problem by that. So now you figure out, oh, wait, it's not just enough to predict the future. You also need to take into account all other kinds of information to make sure that you end up with the right course of action. Back to the umbrella. I said it might not be a good idea to bring the umbrella in the first place. Why is that? Okay, let's think about this a little bit. I heard in the weather forecast, tomorrow it's going to rain. I then realize, wait, tomorrow it's Wednesday. I need to go to work. Let's just assume for half a second I would work here in Tokyo, okay? I need to go to work. The next question is then, okay, I need to leave the house, so probably I should bring my umbrella, but do I actually walk to the office or do I take the car? So how far do I live away from the office? Is it close so I can walk? Is it far? I need to drive. Let's say it's close, so I can walk. Oh, if I can walk, maybe I can take the subway. If I can walk, I should bring the umbrella, but wait again. Maybe it's also going to be windy, so there's a storm. And we all know having an umbrella in storm is not a good idea. Too bad, so maybe I should drive then in any case. So let's take the car. But if I take the car, I also need to take into account that everybody else will take the car, so there will be a lot of traffic. I don't need my umbrella, but I need to start earlier, leave earlier from home to manage to get to my commute in time. That was pretty difficult. I mean, think about this. All I know is tomorrow it's going to rain, and all I want to do is pick my stupid umbrella or not. And now I have this huge decision framework depending on if it's also going to be windy or not, depending on my distance, the travel distance to the office, depending on the behavior of all the other commuters. And that is what makes it so difficult to get just from a prediction, like tomorrow it's going to rain, to something you can actually do. So, a black screen. That's one of my slides. No, it's not. So, this is the big underlying question. I'm fully with Andy. Where is he? With Andy Palmer from Tamer before, who said, like, look, guys, if your data is not clean, there is no point to do all this fancy, what did he call this? Sexy stuff, like this. All this machine learning and predictive analytics, there is no value in doing that before your data is not in a good shape. And I agree. Your data needs to be in a good shape first. I go even a first step further. There is hardly any value just knowing what's going on in your data. You also need to figure out what can you do. So, and this is really where things fall down a little bit. And this slide, I'm sorry for that, is going to be difficult for me. And the main reason is I don't understand a single word. So it starts with BI on the left. So business intelligence. So that's good. Oh, yeah, I'm back. So business intelligence. This is kind of the bottom layer. So you need it. There's no question about this. You need, sure, databases and data cleansing and everything else. But then when you start doing analytics, this is kind of the bottom layer, the minimal thing you can do. But is it actually really that valuable? Well, let's think about this. Business intelligence typically gives you insights into the data of the past. It gives you insights about what has happened. Here on the left, we use our weather example. And here on the right, we use a business use case around customer churn. Okay? Customer churn is important because as a company, we don't want to lose customers. We want to keep them. After we got them, we of course want to keep them. So losing customers is an expensive thing because I need to replace them. So what is BI doing to me? Well, in the weather case, I can see, for example, in the past year, it has rained 231 days. Aha. Good. Very interesting. Doesn't help me at all. What about tomorrow? I mean, really, no. I don't know. Like, interesting information. Fine. Good. On the customer use case here, BI can tell you in the last year you lost 5 million of your customers. Oh my God, this is horrible. This is a disaster. I mean, we only had 5.5 million. So that's not good. But the really, really bad thing is, so what? It's too late. You can't do anything about this now any longer. They are already gone. So what is really the value of this piece of information? It's not that high. Of course, you could now dig deeper and figure out reasons and everything else. But first of all, this is all you're getting. So and while we are on this and we would like to get into the look of the future, people, of course, being not stupid, they came up with the idea, maybe we can predict something based on information like that. Maybe we can build what I call BI-style predictions. So for weather, this could, for example, mean, well, we know it has rained 231 days in the last year. And maybe in the year before, it has rained 245 days. And in the year before, 237. So I think it's pretty safe to say, in the last 3 years, it was raining more than 200 days. Let's create a prediction which tells us next year it will rain more than 200 days. Okay, nice. Still doesn't tell me anything about tomorrow. So it's not even that helpful. Same story here. Let's say those 5 million has been 25% of our customer base. In the previous year, we lost 30%. The year before, 23%. Again, it's probably safe to say in the next year, we also will lose about 20% of our customer base. Still horrible, still not helpful. So that can't be the end of the story. But unfortunately, many people believe that is the end of the story. Now entering machine learning, predictive analytics. Now for the first time, we actually can see what's going to happen tomorrow, what's going to happen to a particular customer. We go down on an event level. So we no longer just think about, well, what is happening in total to the business. We think about what happens in a specific situation. So here, a machine learning model can tell me tomorrow it's going to rain with 95% probability. Or, oh, my dear friend, John Smith, my very well-beloved customer, we are going to lose John tomorrow with a likelihood of 92%. If he's really that important to you, Ingo, then better do something. Don't wait until he's gone. Make him an offer to stay. So this is good because it gives you the option to do something. It gives you the option to think about, do I bring my umbrella or not? It gives you the option to do something about John Smith, give them a discount to stay, but it still doesn't tell you what exactly is it you should do. And this is now something hardly anybody is doing at this moment. And it's crazy, because this is where the biggest value is. This is what we call prescriptive analytics. When we talked about the fancy, the sexy stuff, the more interesting things before, this is really where I get excited. It's not even on the machine learning part, because, hey, yeah, I'm doing this for 15 years. But this is where you combine machine learning with optimization and other information to figure out what is the right thing to do. So on the left, we discussed this already. You walk, well, bring your umbrella. You take the car, leave early so you can commute in time. On the right side, call Mr. Smith. Tell Mr. Smith how important he is to you. And by the way, if Mr. Smith renews the contract, give him a 3% discount. By the way, 3%, not 5, not 10, because an optimization model would tell you 3% is enough to keep him, okay? So what people are doing, what companies are doing is they now call all the churn cases, telcos are doing this, banks are doing this, they call all the people with high likelihood of churn and give them, let's say, just everybody a 10% discount. Well, that's also a very effective way to reduce your revenues by 10%. That's not a good idea. So do what is necessary, do the right thing, but don't do more. Sometimes it could be the right thing not to call John at all. Let's say John wasn't actually, after all, such a good customer. Don't call him. Why should you try to keep a customer where whatever you do, you probably can't keep him, and it's not worth doing it? So this is really like the second bar. This is where machine learning lives. The top bar is where machine learning meets optimization and automation and actually tells you what to do and can even automatically do this. This is what Gartner means if they think about disrupting complete businesses. Okay, enough about umbrellas. I would like to give you a quick demonstration, which I think is a little bit of a fun story as well. And after that, I'll give you 2 or 3 business use cases where people have used it. So first, for this demonstration, I didn't bring the software, but here at the back we have our booth, so we can show you a little bit more there. Just a couple of slides here. I hope you can pick it from there. So, but in the software, what you will see is that we actually analyze, let me go back for a second, analyze the data coming from a database collected by the United States government, which is called the Fatality Analysis Reporting System. And this database contains information about every accident in the United States. Car accidents, bicycle accidents, 2 passengers running into each other, maybe, I don't know. And it contains information about, let's say for a car accident, what type of car was the person driving, how was the weather, how old was the driver, was the person maybe drunk. So it contains all this kind of information, and we can display this. And in the first step, let's do this a little bit in a more BI, business intelligence style pattern. So we analyzed about 250,000 of accidents in this case. And for those 250,000 people who suffered from an accident, you can actually see here on the top right, in the red part of the pie chart, that about 40% had a fatal injury. So they died during the accident. Well, that's certainly not good for them. We could later ask ourselves, what makes the difference between an accident where somebody has a fatal injury and dies versus an accident where it's still an accident, but the driver or the passengers are not dying during the accident? So this is one of the questions we will solve. And there's a little bit more BI-like things. So for example, when do we expect most of the accidents happening? Well, they happen between 3 and 6 p.m. in the afternoon. Well, not a surprise. That's after work. You're driving back home. You're tired. Your boss asked you to do something you didn't like to do. I don't know. You think about the work still, and bam. So while in the middle of the night here, there's much less accidents, well, there is also much less traffic. So shouldn't be a surprise. Oh, most people think Mondays are the days with most accidents because it's after the weekend. People, I don't know, might not be concentrated. That's actually not true. It's not a lot of accidents. It's really on the weekends, Saturdays especially, where most accidents happen. Okay, good to know. Just among the small group of people here, it's also interesting, are more accidents caused by women or more accidents caused by men? What do you think? Any idea? More women or more men who cause accidents? Men? Yeah, by far. We are the worst drivers. I'm sorry. It's like, I didn't show this because it depresses me a little bit, but women are much better drivers, safer drivers, not better maybe, but less accidents. Okay. Let's not go there. But anyway, so this is really BI. So there is nothing like, I don't know, nothing advanced machine learning. But here, actually, for the first time, we apply now machine learning methods to differentiate between fatal injuries and no injuries at all. So whenever you see green here, that means there is no injury. Whenever you see yellow, there was an injury, but the person survived. And whenever you see red, that means not so good, the person died during the accident. So, and here on the left side, you can actually see, you can actually see what are the most important influence factors for fatality. And at the top, you see that the question if somebody was ejected out of the car is the most important influence factor. If somebody was ejected out of the car, that's not good. Well, that's not good for multiple reasons. First of all, it was very likely that you have been driving fast. And an accident while you're driving fast is more risky. But also, it's just probably not really good to fly out of your driving car anyway. So no matter the speed. Restraint system, so like shoulder and lap belt, or for motorbikes, helmet, is the second most important thing. Speed limit, but also alcohol test results, so if you have been drinking or not. And also the age are somewhat important. So let's focus on those 6 things here. So here in the middle column at the top, you see the influence on fatality of ejection. So you can also see on the right bar that if you have been totally ejected out of your vehicle, you're pretty much dead. There is, by the way, a category which is called partially ejected. I still have trouble finding out what partially ejected really means, but I don't think it's good. So if you not have been injected at all, then you see there's a good likelihood, the green bar, that you actually survived. Then here on the top right, the restraint system. The 2 bars on the right side, with non-use and shoulder, those are for cars. And you can also see clearly that if you're wearing a shoulder and lap belt, so it's just a regular seat belt, which is the bar on the right, you actually have a good likelihood of survival even without injury. But if you're in a car accident not wearing them, that's the second bar to the right, much worse. Just quickly on the 2 bars here in the middle. Do you see .com and no helmet? Those are for motorbikes. And the difference is people who have been wearing a helmet or not. There's hardly any difference. Don't go out of this room on your motorbike and don't wear a helmet just because I said there is no difference. Please wear a helmet. It is safe to wear a helmet. It's better to wear a helmet, but unfortunately, it's not much better. I think a real good piece of advice would be don't drive a motorbike at all, because I think that's safer, really. So alcohol is another interesting thing. The alcohol influence on fatality, you see here on the left bar, if you didn't drink alcohol at all, you actually have a higher likelihood of survival. But if you're completely drunk on the right side here, you're pretty much dead in case of an accident as well. That's actually an interesting thing because there's always the saying that correlation and causality are not the same thing. And you can see it here. It's not like you're driving, you have a certain kind of accident, and just because of the case you're drunk, you're all of a sudden dying. That is not the reason. It's the other way around. You're drunk, you're driving like crazy, and then you have an accident, and that's why it's more likely to die in this accident, because you didn't react in time, you didn't use your brakes, you have been driving way too fast, and those are the reasons for higher fatality. So yes, there's a high correlation between being drunk and having more severe accidents, but it doesn't mean that being drunk is the reason. Well, it is kind of the reason, but it's not a direct influence. I hope you get the point. And yeah, often people think like, oh, young drivers there is in particular dangerous. Not so much. If you're getting older, at one point you should probably just take a taxi and stop driving. It's your reaction is just slower. It's nothing unusual, and it's okay. But you should be aware the influence actually is pretty large. Okay, so that's good. So machine learning can help us figuring out what are the reasons. But now we can actually go one step further. Here at the top I have a decision tree model. It's not important. It explains exactly to you for a particular case how likely is it for a certain driver in a certain situation to die in an accident or to survive the accident. And in fact, we use this model here, a boosted naive Bayes model, which is correct in 85% of all the cases. So if you model this and apply this model on another 250,000 test cases, it can actually predict in 85% correctly if you're going to survive this accident or not. And even more important, it can deliver a probability for survival as well. Just like tomorrow it's going to rain with a probability of 95%, here is Ingo is going to die with a probability of 21%. Good to know. And that's exactly what we did actually. I entered my own data here at the top and said, okay, I'm in the age group between 25 and 65. I'm male. I don't drink alcohol when I drive. I never drive faster than 50 miles per hour. And only drive in clear weather. So that's something I can't really change. But what I can change is what type of car am I driving? Can I buy a car which makes it less likely for me to die in an accident? And now, this was a personal shock to me. It turned out that for me, the best car brand I can, by the way, this is a BMW umbrella, okay? I'm a big BMW fan. And it turned out I should drive a Dodge pickup to still die with 90% probability. That's the best I can do. The thing is, you should get the idea that by actually taking this machine learning model and the prediction and combining it with all the possible cars I could buy, I get a recommendation, what is the best car for me, so I'm not going to die. Then one slide, yeah, okay. So, but this is exactly what I just said. What car should I buy for a minimal probability? So I tried this for somebody else. So here's one of my co-workers. She is a young woman, younger than 25, female. Unfortunately, she drinks while she's driving. She also driving with 90 miles per hour in the rain. That doesn't sound very safe. But in her case, of course, she should just buy a Nissan or Datsun, two-door sedan. What? And she has a higher likelihood of survival than me. Do you know the reason? Because she's a woman. We talked about this earlier. They just drive better, safer than I do. Still a little bit depressing. Anyway, so she gets a different recommendation. So this is her car. She should drive to survive. I get a different one. Okay, so this is good. We talked about umbrellas and cars, and you get the basic idea how important it actually is not to just get to the insight part, but also to get to the action part by figuring out what is the best course of action. What car should you buy? And I would do it if it wouldn't be a Dodge pickup. But here are three other quick examples. One of our clients is a large German utility provider. They're providing gas for heating to their clients. So they have 50 million customers, and they wonder who are the people who are actually about to churn, going to a competitor, and who are the people who are really loyal. Did I point to the right things? Okay, good. Who are really loyal. And what do I need to do about this? This is exactly the example we said before. Do I give them a discount? Do I just call them? Sometimes that is enough. Just show them that we care. What is the right course of action? And they actually reduce their churn rate by 30% by doing the right things. They already reduced it by 10, 15% by just knowing who is going to churn and do the same thing for all people. But that was too expensive. Now it's actually even better by doing the right things. Another quick one is coming from a manufacturing environment. This is a concrete manufacturer. They actually, in those concrete factories, have those huge mills somewhere here. And in those mills, you put in stones at the top, and then there's a milling process, and you get concrete at the bottom. The problem is they have sensors everywhere, but you can't really run those mills very fast because then they start to vibrate and eventually break. So the idea is, can I use machine learning to make my settings for the production process in a way that I can actually go as fast as possible without breaking the machine? And here, that is the action. What is the right setting? And then finally, I was flying in with Lufthansa from Frankfurt here to Tokyo on Saturday. It's interesting, again, there has been a couple of seats free in the business class. So if I would be an airline, I would immediately think about how can I actually make offers to my passengers which are not maybe guaranteed to fill all the places, but which are giving me biggest return. So think about this. You basically have 9 free seats at a full economy class. If you make an offer for $1 to upgrade, the first 9 people you ask will upgrade. But now you only made $9 more. That's not good. Or you identify those 9 passengers who are willing to pay most and make a special offer to every single person, which is different from the other people, and get the maximum output. That seems to be a little bit smarter. So those are just 3 examples. What I would like you to take away, but also please visit the booth here with our friends from KSK Analytics, our local partner here in Japan, is that we have this beautiful, beautiful visual platform for doing data science, real data science, but in a fast and simple way. It's visual. You don't need to code. If you want to code, you can do in R, Python, whatever it is. But it's all visual. We can show it to you. You can build those solutions in a couple of minutes. And you should try it out. There's a Japanese version, I think, is available as well. And as I said, let's talk to our friends here from KSK Analytics as well. We can show you a little bit more here. So there's a beautiful platform you can use. But there's also a complete marketplace of tens of thousands of consultants who can help you coming out of your user community. So that's all from my side. I would like to thank you for your attention. I hope you enjoyed it. Give it a try it out. Let me know if you want to learn more. And I think we still have a little bit of time for questions as well. One question? One question maybe. Okay, so I hope you have one. And otherwise, I still will be around as well. Thank you.